function f of x, and we are going to graph it on the same coordinate plane as the transformations. So let f of x equal, and I always like to highlight what I'm going to be graphing here. And then I'm graphing g on the same coordinate plane as f. So your g is going to be your problem for each one. Okay, and then you also have to describe g as a transformation. Okay, and then you can use your table on your graphing calculator to help you plot the points. And that's what we'll do for f of x. Okay, so our g of x is 1/2 of f of x. Notice that the 1/2 is outside of f of x. So do we remember what that transformation is? So it says describe g as a transformation of f. So what type of transformation is this one? Remember? If it's on the outside, it's going to be vertical. Yeah. And then, and then we have to determine if it's a stretch or compression. So this one is going to be a vertical what? Or how do we know? There's a compression. How do we know? Well, you told me it was a compression. Why? Yeah, good. Okay, greater than 0 but less than 1. So vertical compression by a factor of 1/2. Good. Okay, so like you guys said, it's in between 0 and 1. That lets me know that it is the compression. Okay, and it's outside. That lets me know that it's vertical. Okay, so we're going to do a couple things. The first thing we're going to do is we are going to create our table for f of x. So remember yesterday we talked about the cubic functions a lot. This one is a quartic function. So we're going to use -2, -1, 0, 1, 2. And this is where you can use your graphing calculator to help you construct your table. And that would be the quickest way to do so. So 2x to the 4th minus 6x squared plus 1. And then I want you to use your table feature to fill that in. And then you can go ahead and graph the points. Okay, so use your table feature, graph your point. All right. Okay, so for -2, what did we get? Yes. Good. Okay, -1? Yes, -3, right? Okay. 0 was 1, 1 was good, and 2 was 9. Okay, and then you can graph it so that you can see the shape of what's happening. Okay, it's like a little W here. All right, so we're going to go ahead and graph this. And we do want it to span the graph. This one is going to. So -2, 9, -1, 3, or sorry, -1, -3. And then 0, 1, 1, -3, and at 2 and at 9. Okay, so we have like this wave here. So it goes down and then it is going to curve up. I know that's not always easy to do the first time, so be nice to yourself. Use a pencil. And I'm going to curve this here. She is actually not here today. Yep. Okay, and then now what we're going to do is you have your choice. You can apply this, okay, and then you could graph that equation. That is absolutely an option where you would take the 1/2 and multiply it by f of x. This is actually called the rule for g of x, right? The equation, you'd have 1/2, multiply it by 2x to the 4th minus 6x squared plus 1. And a lot of the practice problems we're going to do today are going to ask you for that rule. So 1/2 times f of x, you're going to distribute. When you distribute 1/2, it's just like you're doing what? Multiplying by 1/2 is the same thing as what? Yeah, good, divided by 2. Okay, and so this is going to be the rule for g of x. Okay, remember the rule is just the same thing as the equation. So you can decide how you want to plot g of x. If you want to plug that into your calculator and use the table, you are welcome to, but there's a quicker way. So remember that if it's a vertical compression, does that affect the x-axis or the y-axis? The y. And so what you could do is you could just multiply all the y-coordinates by 1/2, and all of the x-coordinates are the same. So instead of typing all of that in again, you would just use your same x's, -2, -1, 0, 1, 2, and then you can multiply all of the outputs by 1/2. So half of 9 would be 4.5. Half of -3 is -1.5. Half of 1 is 1/2. And then see how these repeat? So -1.5 and then 4.5. Okay, so we graphed f of x. Now we're going to graph g of x. So my g of x is -2, 4.5. So this is my 5, 4.5 is here. -1, -1.5, which is here. At 0, I'm at 1/2. At 1, I'm at -1.5. And at 2, I'm at 4.5. And then again, you have this curve here. And then for b, we're going to use the same equation, but now we have f of a 1/3. And notice where the 1/3 is. That's inside the parentheses. So if it's inside, that means it's going to be what type of transformation? Good. So this is a horizontal. And then when you're deciding whether it's a stretch or compression, remember if it's inside, you do the reciprocal. And the reciprocal of 1/3 is what? 3. So the factor is 3, which means it's a horizontal what? Stretch. So horizontal stretch by a factor of 3. Okay, so we are going to look at this rule. Okay, so the rule is plugging in that 1/3 into the original. Okay, so your g of x equals 2 1/3 x to the 4th minus 6 1/3 x squared plus 1. So when you simplify this, we are going to just do that step by step. Remember your order of operations. PEMDAS, right? Parentheses, exponents, then you multiply and divide at the same time, add and subtract. So I have to apply this 4th power. You do have to apply it to the 1/3. So 1 to the 4th is 1. 3 to the 4th is like 3 times 3 times 3 times 3. So what's 3 times 3? 9. What's 9 times 9? 81. So this is 1 over 81, x to the 4th, minus 6 times. Guys, what is going on back there? Okay, and then we're going to simplify here. Okay, and then let's reduce this. So what goes into both 6 and 9? Okay, so if I divide by 3, so like this would be 6/9. So if I reduce, it would be 2 over 3 x squared plus 1. And then again, you're going to have the option if you want to plug that in, okay, and if you want to use those points, or the quicker way is going to be to look and see how this is affected. If it's horizontal, does it affect the x or the y? Which one is the horizontal axis? The x. So all you're going to have to do is multiply the x coordinates by, it's a factor of 3, you're just going to multiply them by 3. And then what about the y coordinates? Yeah, y coordinates are the same. Okay, so fill out your chart for me using those 2 rules. Okay, so again, I do recommend using the rules to find them so you have nice points instead of having to work with your decimals. So when I say multiply the x coordinate by 3, remember, we're using our original function. Here's our original function. So times 3 would be negative 6, times 3, times 3, times 3, times 3. Okay? And then the y's are staying the same. So 9, negative 3, 1, negative 3, 9. Okay, and the f of x is the same. So negative 2, 9, negative 1, negative 3, 0, 1, 1, negative 3, and 2, 9. Okay, and then you're connecting those with a curve. So I like to kind of do one side there, and then I curve this one down here. Okay, and that's my f of x. Okay, and you can color code these, or you can also just like label which one is which, that's fine. And so this is a horizontal stretch, so it should be wider. So I have 0, 1. Okay, and then I have 3, negative 3. negative 3, negative 3. Here and 9 here. Okay, so I'm going to curve this. And then I'm going to curve this one. Yeah. How'd you guys turn out? You got these? Good. I know that the graphing does take some practice there. Okay, and then we are going to finish this page up with combining the transformations. Now, this is very similar to what we were doing with the rules. It's just the combination is going to perform one transformation after another, and we want to do that in the order that they're given. So this says write a function. Okay, directions are going to say either write a function, sometimes they might say write a rule. Those are the same things. Okay, and then it's write a function that transforms. So for this one, it's f of x equals 6x cubed minus 3. That's the function we're going to transform in the following ways. You can support your solution with a graphing calculator. That means that you can graph your final answer and the original and see if it does perform those operations, but that's not something you have to do, but you're going to see the same exact directions in your textbook. So this says to compress vertically by 1/3. That's what we're filling in. And we are going to shift 2 units right. Okay, so we're going to compress vertically. That's the first thing. And then we are going to shift 2 units to the right. Okay, so for step 1, you are going to write your rule. For a vertical compression by 1/3. Okay, so in order to write our rule for that, we can use our chart that is on our front page here. Okay, so a vertical compression. Okay, so if I look at that, the vertical compression, if I can't remember, I'm going to go here. Vertical stretch and compression, it's A times f of x. Okay, so if this is A times f of x, in this case, what's our A value? 1/3. So it's 1/3 times f of x. Okay, so if it's f of x, all you have to do is plug in the entire equation. So it's 1/3 times that f of x, which for this one, f of x is 6x cubed minus 3. And then you do have to simplify. So we are going to distribute to both of these. Okay, so 1/3 times 6 is 2, so this is 2x cubed. 1/3 times negative 3 is negative 1. This is my new function that I'm going to use in step 2. Okay, so in step 2, we are going to write the rule for the horizontal shift to the right. Okay, and I knew it was horizontal because it's going to the right. So right and left are a horizontal transformation. Okay, again, I can use my chart on the front. If it is a horizontal shift, then I want to look here, and then if I'm going to the right, I know that it's going to be minus. Okay, so I'm going to have f of x minus Now this one you have to plug in any place you see an X. This one, there's only one X here, but you may come across some where there's more than one place you have to substitute it in. So for this one, you have 2 x cubed minus 1. Okay, and then what you're plugging in for x is your x minus 2. And then you have to simplify this part. You can decide how you want to simplify it. If you want to write it out 3 times and then multiply and then distribute, you can. Or remember yesterday we talked about what's a really quick way to do that is using what? Yeah, let's use Pascal's. Because what's the third row? 1, 3, 3, 1. And then this is x, so this is x to the third, x to the second, x to the first, and then x to the 0 is just 1. And then the part you have to be careful of is this is a negative 2. So negative 2 to the 0 is 1. Okay, and then you have negative 2 to the first. What's negative 2 to the second? 4. So you can decide. You can do negative 2 to the second equals 4. Or if you want to just put the 4 in there, that's fine. Negative 2 to the third equals negative 8. And then you always multiply straight down. I like to write that here, so I'm not writing it out a bunch of times, but you can decide, okay? So it's 2 times, and then I'm going to write that in here. So 1 times x cubed times 1 is x cubed. So we go straight down, right? X cubed here. And then 3 times x squared times negative 2 is negative 6x squared. So I'm going to put that here. And then this would be 3 times x times 4, so that is 12x. And then 1 times negative 8 will be negative 8. And then the rest of this stays the same, right? I have the 2 and then I have the minus 1. So to simplify this, I'm going to distribute the 2 to everything. 2x cubed minus 12x squared plus 24x minus 16. And then I still have that minus 1 on the end. As we do this more, you guys can just, when you do this, you can apply the minus 1s. You don't have to write it out another time. But then this will be your final answer. Combine your like terms. Negative 16 minus 1 will be negative 17. And that will be your g of x. That will be your rule. Alright, and then go ahead and go to part B. So part B, you're using the same f of x. So go ahead and do that.